Very good morning, Brazil. Good morning, Americas. Very good morning to our audience in Europe. Very good afternoon. Okay, now my video is here. Very good afternoon to Middle East region and Europe, and very, very good evening to our clients and partners in Southeast Asia and Australia. We have so many different time zones here today, and ICC is so very glad to be able to gather our valuable clients and partners around the world. We thank you, each one of you presence very much. I am Isabella Barros. Some of you already know me, business manager at ICC. We just played ICC 30 years anniversary video. And being part of this incredible history is a reason of extreme fulfillment to me. ICC Animal Nutrition is a benchmark model in the research and innovative solutions. We are recognized in Brazil and internationally for providing innovative, natural solutions for animal nutrition and health, with great market share in over 70 countries. With 30 years of history, the company's mission is to add value to the animal nutrition and feed the world with healthy, safe, affordable, and available products. Our passion is to help the industry to accelerate its move away from the antibiotics with sustainable and sophisticated alternatives. Today, we have John Ratcliff with us for the very first time. A great honor to ICC, and I would like to say a few words about John before letting him come to the stage and deliver his presentation. John counts with 15 years in the UK feed company JBB Agriculture, and ABN responsible for 4 feed mills with combined output of 415,000 tons per year. Plus, John counts with 25 years running FACS Limited Consultancy, specializing HACCP-based food and feed safety systems from farm to further processing throughout South America, Europe, and Asia. 20 years consulting for the UK's leading supermarket Tesco on animal feed and animal feed mills and supply chain auditing. John will talk today about maximizing feed mill and increasing profitability. Extremely relevant theme due to the scenery we are living today. I would like to remind you all that we will have our meeting room chat. You can write down your questions, and in the end of John's presentation, we will select some of the questions so that he can answer them on time online, and later on we will gather all the questions and they will be duly replied by email to each one of the subscribers. John, thank you so much. The stage is yours.
Thank you, Isabella. And screen sharing says my, okay, there we go. All right, good. Well, hopefully everybody can see that. And welcome everybody from wherever you are in the world. It's great to hear we've got people from so many diverse continents attending today. And I hope what we have for you today is going to be of relevance and interest. I think in my many years in feed industry, I can't remember a time when the pressures on feed mill efficiency and profitability have been so great. Previously, we've had raw material peaks and troughs, which have impacted. But right now, we can add to that fuel, energy costs, we can add labor costs, and a very uncertain global supply chain situation. So with that, it's really important that feed mills take stock of what they're doing and really try to understand how efficiently they're operating and where they can drive further efficiencies through the process. And that's what we're going to talk to you about today. Okay. Now, one of the commonly quoted adages is you can't manage what you can't measure. And that's really my theme today, is that unless you are in a situation where you can see clearly in real time what is happening within your business, it's very unlikely you're going to be able to make the changes necessary to improve the overall efficiency of that plant. And I'm talking about real-time data, not data that is written down, put into an Excel that you look at once a month. This is visualization of what's happening in your plant. Now, capturing data in this day and age is not difficult. That is the good part of this solution in terms of both cost and availability. There are many software programs that just require connections of power meters or other smart meters, a simple converter, and you can start to capture data. And with the right type of software as well, you can then manage how that data is presented to visualize the key parameters that you're concerned about. And we're going to show you some examples of that later. I'm going to talk a lot about overall equipment effectiveness, or OEE. And this is a standard which has really come in from other industries, which often happens in the feed industry. We pick up other industry standards and incorporate them. And overall equipment effectiveness is used very much in automobile production, for example, where they are looking to measure the gap between the actual performance and the potential or expected performance, and can identify the percentage of planned production that is truly productive. Because in my experience, most feed plants do not operate at their operational capacity for a number of varied reasons. And we're going to try to look at some of those during the course of this presentation. Now, why is that? Well, one of the reasons can be, first of all, that when equipment is set up, we can talk about any particular key machinery process or line in your feed plant, maybe the performance was running according to expectation, but over time, and sorry, let me just get that. Over time, then that performance starts to decline, so that when we go and look at the current situation, we may find there's quite a deviation between the expected performance level and the actual performance level. Another scenario would be, and this is not unusual either, that when either from a new build and a commissioning perspective, or just a new piece of equipment, maybe a pellet machine or a grinding machine, hammer mill, for example, that actually the setup right from the start was never according to the expected output of that machinery. So in fact, it's been accepted that you're running at, let's say, 10 ton per hour instead of the rated capacity of that machine or equipment of 12 tons per hour, for example. And nobody has really challenged that. It's become an accepted norm rather than trying to understand, well, why is that? That's not how the machinery or that process line was designed to produce only 10 ton per hour. So OEE data, why it is important? Well, number of key benefits, which we can see here. First of all, improvements in machine performance and production process clearly result in significant cost benefits. So we ignore it at our peril. Understanding what, when, where, and why performance is lost in order to create solutions. If we don't understand the root cause, how are we going to resolve the issue and create a solution? OEE helps to decide what maintenance policy to adopt as a best fit to operational requirements. It also helps to decide what process adjustments need to be implemented. It may help you to direct resources where they're needed for maximum benefits. So when you're reviewing your budget for CapEx, for example, you know, the OEE may actually identify where you should be focusing in order to obtain the most significant return on investment or the quickest return on investment. It allows you to measure performance as a means to achieve expected results. So we can set KPIs according to OEE and also measure effectiveness of the measures taken to improve performance. That's really key. What we're saying there is whenever you implement an initiative to improve, it's really important that you monitor how did you achieve against that expected improvement, particularly if CapEx is involved, because if you want to justify future investment, it's very important that you can show that your initial investments were the right ones in terms of investment and payback. So OEE really focus on three aspects of production, and we can talk about an individual machine like a pellet mill at this stage because it's quite easy to visualize. And the parameters really are, is the machine running? How fast is that machine running? And how many products meet quality specifications? Those are the three parameters that OEE is going to measure, and that provides this overall equipment effectiveness. And the calculation for OEE is simply those numbers multiplied together to give you a % out of 100. In this example, you can see that the availability was scored at 77%, the performance at 95%, and the quality at 92. So the overall OEE in this example was 67%. Now, what is considered good, acceptable performance obviously depends on site to site, because it will very much vary according to the age of the plant, the type of equipment you've got, the overall setup and design of the plant. But generally, I would say performance-wise, you should be looking between 60 to 70% as an acceptable, a typical area. High performance levels will be above 70%. Areas that need improvement would be anywhere up to 55 to 60%. So that's just a guide, but really the number right at the start is not important. What is important is to understand where you are and then where you think you can get to through analysis of this OEE data. Now, availability is a measurement of the expected time that the machine is available to run, so therefore the planned production time, against the actual run time. So in the example you can see here, if the planned time was 60 minutes and the actual running time was 50 minutes, then your availability is 83%. So one of the key points clearly is we want to understand how long the plant should be running, and run or actual operating time will depend on how long did the plant actually run. It will take account of all events that may have stopped the planned production. For example, breakdowns, die changes, cleaning out of the line, for example, waiting because of a run out of raw material, etc., etc. And these computed as planned production time less those stop times. And stop times, as I've already said, can be machine times and operational down times. So you're going to have a planned time, and then the machine running will calculate your actual operating time. So if we think about machine downtime, periods when the plant or equipment is not available or fails to perform to its primary function as a result of either mechanical, electrical, and other machine-related failures, may be a result of a planned or scheduled downtime or maintenance. So in which case it's already planned and expected, or it could be unplanned, as we said, as a result of a machinery breakdown or a bottleneck in the process. So from a strategic perspective, we want to limit unplanned breakdowns to a minimum and clearly properly time planned machine downtimes so they don't reduce the total amount of available production time. How do we do that? Well, one of the key areas is an effective maintenance program. A good maintenance program should be able to combine the right mix of the three maintenance policies, which are corrective, preventative, and predictive. The more corrective maintenance that you're doing, the less availability percent you will have in your OEE, because corrective by definition means you are reacting to a situation. That machine is already broken, there's already downtime involved, and that is going to count against your availability. So having a good maintenance program results in less unplanned breakdowns. It's safer to do maintenance works and operate the machine because you're working when the plant is generally not operating. There's less total maintenance and repair costs, and clearly also the cost of the labor involved in that maintenance. There should be no extra cost for emergency delivery of spare parts, because if it's correctly planned, they should be already in stock. It will result in improved product quality and less reprocessing and wastage, less tipping of product onto the floor, back into reprocess, and the economic life of the equipment is also prolonged. So periods of plant unavailability caused by factors other than machine downtime could be product changeover. So changing hammer mill, sifter screens, dies, etc. Product clean out, particularly if you are producing feeds with coccidiostats or antibiotics, or if you're involved in aggregate production, it could be because of the size of the pellets have to be cleaned out from pelleting or extrusion and drying lines. Could be delays due to raw materials or packaging, premix availability, maybe a lack of finished goods warehouse space. So you physically are not able to produce to stock because you don't have the necessary space in the warehouse. Certainly in some parts of the world, power outages are quite common. So that's clearly going to affect. Lack of manpower could be an issue, particularly if you're relying maybe on contract labor for packing operations and they simply don't turn up, or you don't have the manpower that is scheduled to arrive for that particular shift. Shift turnover. So, do the night shift, do all the operators on the night shift turn up according to plan? It could be other issues such as boiler steam pressure buildup, fumigation, pest control issues that require downtime, or in cold climates, for example, your liquid oils that you use, maybe palm oils and some of the harder animal fats, they become solidified and then you're unable to spray product because of severely cold weather factors. So many different issues that can lead to operational or process downtime. But the point about OEE is that it allows you to go in and analyze and understand what may be the common causes, and therefore what you can do to limit those from continuing to affect your availability. Now, in most process plants, one of the areas you would look at to understand availability optimization is batching capacity, batching cycles. As you know, in pre-grind and post-grind plants, there is a cycle of usually from blending or dosing and grinding through to the mixing and then through to pelleting. So the batching capacity in terms of metric tons per hour is calculated by the equation you can see here, which is the batch size divided by 60 minutes for 1 hour, and then the actual cycle time. So normally the cycle time, because of changeover, is longer than the 60 minutes. And this leads to a more conservative and more realistic calculation for the plant capacity. So it doesn't run at the full batch size. So for example, three metric tons times 60 minutes, I'll give you 120. That very rarely is the case. There are other factors which slightly reduce that. When equipment suppliers specify plant capacity, they are referring to a continuous cycle time without product changeovers or cleanouts or other bottlenecks in the line. This is not to be understood, this is not to be misunderstood as the guaranteed plant capacity, regardless of the number of feed types and the volume of each production run. So example, installed capacity versus available capacity, and then available capacity versus utilizable capacity. So these are two dynamics which are going to impact how much feed you actually produce against what is specified for that particular production line or a particular piece of the equipment in that line. Now, for pre-grind feed mills, quite often, if not planned correctly, there can be a delay, a waiting time between the weighing and the grinding and the end of the mixing cycle. So there is a delay before the train conveyor and the bucket elevators, for example, can start up again because they're waiting for the discharge process from the mixer before they can start the dosing process again. Not all feed mills, obviously. If you're designed at an optimal rate, you won't have that kind of delay, but there will be circumstances, and I've certainly seen them, where there are delays as a result of that kind of inefficiency or lack of being able to provide the ground material to the dosing bins and through to the mixing in adequate time. In post-grind mills, of course, it's a different situation. Here we're grinding after the dosing into the mixing. So the delay is quite often a result of the delay between batching and the two sets of batching before they go to the grinding operation and then through to mixing. And again, that can be through to the capacity of the conveyors that are transferring raw material to the dosing bins, and from the dosing bins to the scales, and scales through to the mixer. So a good study is to analyze your batch cycle and see whether you have any inefficiencies in the line that are creating a bottleneck. And if you do have a bottleneck, what can you do to resolve that issue? So here's just some examples in terms of pre-grind mills. If the mixing cycle or pelleting bill capacity is the bottleneck, then some things you can do maybe is to shorten the mixing cycle time. This could be done through increasing the mixer shaft RPM, for example. But of course, you've got to be very careful that that doesn't have a negative impact on your CV, for example. It'll also maybe create more wear and tear. So you could also consider changing from a ribbon to a paddle mixer, for example, to reduce your mixing time. Increasing the batch size, but of course there is a limit to increasing the mixer load, and you may also need to increase weigher capacity or increase the number of weighers if you're thinking of doing that. Ideally, the grinding capacity should be about 2 times the mixing capacity, and of course then you need the conveying capacity after the mixer in order not to cause a bottleneck through to the pelleting or mash finished product bins. So you may need to increase speed of conveyors, and you may need to increase the size of the conveyors if there is a bottleneck. And of course, if the bottleneck is in the pelleting area, if it's not because of the pellet mills themselves, it could be because of the pellet bin capacity. And modern designs would have usually a minimum of two pelleting bins with more than adequate capacity to keep that pellet mill running all of the time. But in some plants, that is not the case, and they're physically waiting for that product to become available. Post-grind systems, then, if you're looking to shorten the post-grinding cycle time, we can increase hammer mill size capacity, or maybe install additional grinders, rationalize the particle size to increase throughput by not unnecessarily grinding too fine. Quite often I see, in some plants that they grind, 250 micron. That reduces throughput. It's also maybe not optimal from a nutritional perspective, but it may be done for customer pellet quality reasons, but actually that's severely limiting your output. So looking at how you can increase that, and therefore increase the output of your hammer mills, would be an advantage. And of course, applying variable speed drives allows them for determining the correct screen and tip speed combination to achieve correct particle size. So you don't need to keep changing screens. You can determine particle size through adjusting the speed of the drive. And after the post grinding, rationalizing sifter mesh size, so you divert more feed materials directly to the mixer and reduce amount of coarse material going back into the hammer mill, will also result in an increase in throughput. Other things to consider: conveying capacity before the grinder, I already talked about, and the mixing capacity and conveying capacity to the mixer should be sufficient not to cause a bottleneck. So in a post-grind system, any fine material, raw material, shouldn't need to go through the grinding. You can bypass that, go direct into the mixer, save energy, and also increase the speed of the grinding time. So how do we prevent or minimize operational or process downtime? Basically, start with a good plant design and process setup aligned with product specifications and volume requirements. So obviously for new builds, this is fundamental work that you need to do in order to make sure that you're optimizing batch size, the number of lines, the number of product types or SKUs, the volume of each of those product types, consideration for special requirements. So for example, heat treatment, retention time on conditioners for heat treated feed, for example, number of raw materials and ingredients. How many raw materials and ingredients are you going to use? One of the most common issues I see is that feed mills are designed with too few dosing bin capacity and also weigh scale capacity. And that means you're limited in maybe the type of raw materials you can use, number of type of raw materials, but also you may be forced to be including low weights of raw materials in bulk into a dosing scale that is not designed for such a small weight of ingredient. So normally 1.5% of the scale size should be the minimum that will be going into that scale. Inventory space requirements for finished goods and raw materials, so adequate warehouse storage for both bulk, bag, and liquids. And of course, if power out is an issue, then backup power to minimize the downtime when you do have power outs. And effective production planning and scheduling is really paramount. One of the hardest aspects of running a production plant, feed mill, is determining exactly how much to produce, when to produce it, and what materials need to be ordered and when. You can't do that unless you've got a very good sales forecast that is accurate and updated, possibly every 3 months, to reflect the current commercial situation. Otherwise, it's very difficult for a feed plant to begin to plan and schedule. And you need to decide on an inventory policy for commercial sales requirements, for internal volume requirements, and of course, custom mix requirements if you're producing like OEM products for larger customers. But again, one of the largest inefficiencies in feed plants is small production runs. And many times I would challenge those plants that are producing small production runs. How much are you actually generating from a profit perspective on that SKU, and how much does that SKU cost you to produce? So if you're producing a small amount, a 1 ton lot of a 2.5 millimeter pellet, the cost of that is significantly higher than a 10-ton run of a 3mm product. So have you accurately reflected that in the sales price, and is it going to still make you money? If not, you should put a line through those inefficient SKUs and try to work to a minimum order size. Of course, the other aspect in that is lead order time. And of course, the more lead order time that you have, the better that you can manage that planning and schedule as well. So good organizational planning coupled with the right personal training. So the organization plan should have flexibility for relief systems. So training operators who may be looking after the pellet mill to do maintenance and vice versa. The people who are doing hand ads, for example, they can also do some routine greasing maintenance and maintenance checks. Identify functions which can be multitasks, but provide the proper training for that. Incentivize labor-intensive sections. So where you know you've got high labor requirements, particularly in packing operations, for example, then if you incentivize them, then at least they should be trying to optimize the output to the maximum rather than just working at a fairly pedestrian pace. And of course, you then have the question, how much of the process in the plant should you be looking to automate? Because automation of feed plants now is a standard feature in most parts of the world, but the degree of automation does vary significantly country to country, region to region. So in many areas, there is still a large scope to be found in terms of capacity optimization through automation and trying to then reduce the labor extensive sections of the plant. So we talked about availability, when and how long the machines or the line are available for production. The other calculation that you need to know is the performance within that available time. And you can see here, there's two examples: total production or runtime divided by the rated runtime, the capacity rated runtime for that machine, or actual production versus actual rated tons. So if you produce 14 metric ton per hour and the rated capacity of that machine is 18 ton, then that's a 78% efficiency. So this calculation within OEE takes account of anything that causes the manufacturing process to run at less than the maximum possible speed when it's running. Not downtime, we're not talking about that, we're just simply talking about the output against the rated capacity. And in the example here, the runtime equals the production time less the stop time, which is 24 hours minus, say, a planned stop time of 4 hours. So your running time is 20 hours. And within that 20 hours, your ideal run rate is 10 metric tons per hour, which would mean you produce 180 metric tons, right? But in terms of your performance, as we saw here, then if you're producing 180 metric tons over 20 hours, not 24 hours, at 10 ton per hour, then that's going to be a 90% efficiency, not 100%, because you're running at 20 metric tons within that 20 hours. How to improve pellet mill throughput? Focus on pellet mill, because that's one of the areas where we would see product performance capacity is underperforming. That can be for many, many reasons. I've just given a number of examples here. Correct steam conditioning is fundamental. So conditioning fill percent and retention time. Still surprises me how many plants don't actually measure or even open up a conditioner and look at the percent of fill inside. If you're not at 45 to 50%, it's not going to be operating at its operational capacity and efficiency. Choosing the appropriate L/D ratios for improved PDIs in your dies to conform to lower fine restrictions and minimum fine returns to the pellet bin. Appropriate size selection of sifter screen So after pelleting, again, to conform to the appropriate product size requirements without sacrificing fines, restrictions, we're going back to the pellet bin. All of the returns, whether it's going back to the crumbler or the pellet bin, are reducing your capacity optimization. Correct die selection to increase throughput without sacrificing feed efficiency. So what is your target for PDI, and how much is that critical to the type of die that you're using? Is there scope to actually have a slightly less restrictive die so you can increase output, but not sacrifice your physical quality? Correct crumbler setup, I would say most plants probably don't run crumblers as efficiently as they should be for a number of reasons. That can be due to roller selections. It can be due to inadequate feeder sizing onto the crumblers, many different reasons. But it's not uncommon to see returns coming off a crumbler 30–40%. And that's a 30–40% reduction on your output from those pellets that are produced from that pellet mill. So whatever you do to improve the quality of the crumbs and reduce that percent return is going to improve your performance. And of course, I mentioned automation before in terms of optimizing for availability. It's also very appropriate in terms of maximizing, for example, on a pellet mill, how efficiently nowadays you can run a pellet mill with automation as opposed to manual control. The final parameter we mentioned was quality. So conforming product divided by the total production that you use. Now, here, of course, it's a bit of more of a challenge because those two other factors we can measure very easily in real time. But for quality, excuse me, that's not as easy to measure in real time. So in many cases, the number is maybe set as a standard, maybe at 100%, for example, and then adjusted at the end of the batch run for that particular SKU based on how much product has been rejected from the line from that particular run. So the conforming product is the quantity of feed that has passed quality standards, takes into account manufactured parts that do not meet those standards, including any that have been taken out for rework. And as I said, therefore, typically, maybe this number is entered manually at the end of the run. There are, however, ideas in place already where they are trying to, through sensor development, try to measure in real time how much is being diverted, how much is not available because it's going to be put back for reprocess, and therefore calculating that automatically into the OEE. So having talked about the parameters of OEE, how we measure them, I said at the beginning, the architecture is quite simple. With technology today, we can set up measurements on all of the key machineries using a variety of sensors. Digital power meter is fundamental, but then other sensors such as steam flow meters, gas flow meters, temperature meters, etc. That data can be gathered and processed and then stored in a cloud and then sent to the whatever display you require, whether on a iPad or on your phone, whatever format you want. You can have that information and data available in real time. And those displays, as I said, make it much easier for management and operators to understand how efficiently the plant is operating. They can visualize it and they can see the numbers, and they can also see how they are producing against the targets that have been set either through KPIs or just as the targets within their OEE system. And the beauty is also we can measure within the plant. We can also measure between plants. Now, of course, some of the measurements are not going to be directly transferable because of different plants, different designs, different machinery outputs. But the principles and the energy efficiencies, for example, it's useful and very helpful to be able to do this, certainly from an investment perspective and also from a management perspective, If we know one plant energy costs are running higher, what is the reason for that? Do we have the data? And if we analyze the data, what are the causes of that? And what can we do to reduce that cost? And as I said, from the cloud, we can produce web reports. These are customized to individual customers, so you can set them up in whatever format you like, whatever the company or really the parameters that they want to look at in terms of OEE. Simple example here for the availability, the quality and the performance, for example. Here's another example just from 3 pellet mills, same process line, 3 different lines, same feed mill, and you can see the difference in performance between those 3 pellet lines. You clearly want to know why is one running at 30%, another at 47, another 52. Most probably it's something to do with the SKU, the formulation. And this is the other important aspect of having measurements of OEE based on each formulation. If you know that a particular formulation is going to reduce your OEE, your operational efficiency, by 10 or 20%, then you should be dialoguing with the formulator and nutritionist to say, hey, this formulation is not cost effective. It's slowing down my production. What can you do to improve that? And that's really important in this time in our history because of raw material costs. Formulators, nutritionists tempted to use cheaper products, maybe harder to grind, harder to pellet products, cassava, sorghum, for example, tapioca, these type of products, they're going to have a direct impact on your production efficiency. So for the saving, because if it's done on a least cost basis, how much is that actually costing on a per ton basis for that SKU against what it's costing you to produce? And unless you have that information, back to that adage, if you don't monitor it, you can't manage it. You can't present that information to formulation and say, hey, this is the result of that formulation, and we need to make changes so I can improve the efficiency and output from that particular SKU. We can then set up displays which identify the full production process, from grinding through to packing, the targets, the efficiencies, the capability, all of those formats. As I said, infinite number of ways you can display, but it just gives you a very instant real-time indication of what's happening in the feed plant. And that's what you need in order to make the changes which are going to drive efficiencies in the shortest time possible in your feed mill production process. And same for energy. Energy cost is really a demanding factor right now. Peak demand factor also is going to impact your cost. So how you manage it, how you manage your energy, how your energy is billed in terms of times of the day, and how you plan production according to your energy costs, but ultimately to make sure you've only got machines running that necessarily need to be running, and ensure all other items are switched off and not running idle, burning up valuable electricity or other energies to optimize your overall energy efficiency. And this is really, I would say, a must-have requirement if you're going to stand any chance of trying to manage and optimize your energy costs through these very challenging times. So in terms of energy efficiency, it's a variable cost, therefore revenue budget for each site is the starting process. You need to be able to plan what is the correct energy cost per kilowatt hour per ton based on the forecast and the budget that is in place for that individual plant. Bench those costs against volume forecast for the different types of products, pellets, crumbles, mash, extruded products, for example, and then think of energy saving initiatives, which could be around fuel efficiency, boil efficiency, wastage, steam leaks, etc. Many areas that you could be losing energy efficiency within the mill. Same for efficiency of losses for raw material. So we often talk about shrink. For raw materials, losses on arrival, in storage, both physical lossage and moisture lossage in storage. accuracy of inventory measurement procedures. It still remains a substandard technology in many feed plants, where people go around counting, dipping bins, trying to estimate stock levels, misleading information that gives us inaccurate information and gives us the impression that we're not losing stock when actually we are, or vice versa. So reviewing stock taking procedures and technologies for stock taking procedure is a recommendation. And of course, shrink losses in the process are around moisture management. And again, the cost of losing moisture now has never been higher as a result of the high cost of raw materials and therefore the higher cost of finished feed. Every percent or 0.1% of moisture that you can retain in your feed is going to be very valuable. So how you do that obviously depends on where those losses are occurring in the line and what you can do at those various interjections within the line to reduce the moisture loss. But it really is a critical part of the process and one that you should not be ignoring. Cooler and drying efficiency. So, overcooling, over drying are going to be costing you a lot of money. Those pellet and crumble sieve returns I talked about that are being reprocessed. It's not just the cost of the fact that they're going to be reprocessed twice or 3 times. It's actually the denaturation of the of some of those heat stable raw materials, and particularly vitamins and feed additives that are going through a heat treatment process 1, 2, 3 times maybe. It could be around weight tolerances on your scales, your batching scales, weight tolerances on your bulk loading or your packing scales. And if you're packing into bags, what is the tolerance on the weight on the bag and how much are you giving away? Even if it's only a gram or a few grams per bag, if you multiply that across all of the bags produced in a month and then a year, it could be potentially a very significant amount of money. And then of course, spillages, leaks, reprocess. This is where maintenance plays a key part. So don't be fooled into thinking maintenance is an easy cost saving. Reducing maintenance usually leads to additional costs in other areas of the business. For personal efficiency, people management, then labor costs, we need to look at shift patterns, the manning levels for those shifts, the operating hours, and of course requirements for overtime. And therefore having, as I said, a good operational budget is the key starting point to have that planned efficiently. The level of automation, process and key equipment is getting much more sophisticated. And we know many plants now, of course, new build plants that can be running with 3 or 4 operators only, bulk only in most cases, or fully automated packing, robot stacking and warehouse loading systems. It's been available for a number of years, but certainly in Asia, some of the plants have been slower to adapt to that technology, but now due to costs are having to relook at that and really look at how they optimize their human resource within the plant to its most efficient level. And we talk about Industry 4.0 and smart sensor technology. There's a huge amount of technology now that is already in feed milling and will be coming into feed milling that is going to improve availability, is going to improve performance, and it's going to improve quality management. So endorsing those is going to be a benefit to your business. So for performance efficiency perspective and management, setting up of your hammer mills, your mixer efficiencies, your conditioning and steam quality, looking at pelleting. Anyone running pelleting with a manual operator simply cannot produce the level of efficiency of output. I don't care how good the operator is, because whoever they are, they're going to change on the next shift, or they're going to be on holiday, or they're going to be off sick. They're not continuous. And the sort of programs and software programs that automate pellet mills now and extrusion plants now are far more efficient than a manual operator can do. And I would include semi-automatic systems as well. You know, simple PDI loops, they're not efficient, and they can't ramp up production as quickly and ensure output at the highest level compared to fully automatic processes. And even when we look at cooling and drying, there are automated processes here that can consider other parameters that other than the standards. For example, in cooling, bed depth and temperature, there are other parameters: moisture of the pellets inside the plant, the airflow, the volume capacity of the cooler, for which programs are now developed that can help optimize discharge to prevent those losses of moisture that I talked about earlier. So with all of these initiatives and with all this data that you're generating, it allows you to then look and be in a position to talk about key performance indicators. So measurable values that are going to demonstrate how effectively the company is achieving their key business objectives. And high-level KPIs are the factors that will determine the bottom line company profit, while the lower level KPIs may focus on the process within the departments or teams or individuals. And those KPIs are used in the feed mill to evaluate success at reaching targets and for achieving the longer term aim of reducing manufacturing costs and improving productivity. So find out where you are, and then what is the achievable target to improve, set that as a key KPI, and then measure it against it. And if you don't achieve it, okay, what was the reason? And if you have the data available, you'll be able to understand why you are not achieving that KPI and what you can do to change and therefore allow you to meet that KPI target, either through simple changes within the process, or maybe it requires capital investment, CapEx, to improve some part of the plant in the process. And here are just some of the example KPIs that you may expect to see, and I'm sure many of you are already operating within your plants: stock loss or gain or shrink, the percent of returns and reprocess, either percents of reduction or finished goods produced, your output in tons per hour per machine, your electrical consumption and kilowatt hours per ton produced per shift or per run or SKU, or perhaps the amount of steam, the volume of steam produced per ton, the labor cost, so tons per man hour, for example, quality percentage we talked about already. So what percent of the total feed that you produce is saleable goods. Maintenance performance, so how are you performing downtime due to breakdown? Setting a KPI to limit that to as low a level as possible, and then measuring against that. And of course, safety, for example, days since last accident, or any other parameters that however you want to measure safety within the plant. And here's just an example of a breakdown maintenance KPI by month. And you can see that the target was set around 3%. So they're below the target, but slightly concerning thing is that they are on an increasing trend. So you'd want to analyze, and the analysis is done down below on what may be the factors and therefore what needs to be done in order to bring that back into a corrective state. So visualizing KPIs is very important and easy for people to track where they are against each of those targets. So in conclusion and in summary, data, I said preferably real time, is required to understand performance efficiency. If it's not in real time, it's unlikely that you're going to make the right interjections, the right changes in the right time in order to correct efficiency without it running for such a long period that you then are accounting for low efficiency at the month end, for example. Real-time data is what you want to be achieving. Having that displayed as required on whatever tablet or format you want of the key parameters that you want to measure. And then understanding the bottlenecks within each plant that are impacting your availability, your performance and quality. And then finally, setting those KPIs to evaluate success at reaching targets and achieving the longer term aim of reducing manufacturing cost and improving productivity. Because I can be pretty assured that in almost all feed mills, there is scope to improve efficiency. It's just understanding from the data where and what you need to do, and then to be able to measure that and understand the success or not of those changes that you've made. So with that, I'd like to thank you for your attention, and I look forward to any questions that may have been submitted during the course of the seminar. Thank you.
John, thank you so much for this great presentation. I am so glad. I hope the audience enjoyed as much as I did. John, we have few questions here from different regions. Are you ready?
I'm ready. Yes, far away.
John, first one, which ID ratio diet is best for shrimp feed to increase the feed stability? First question from the audience.
Okay, right. Well, shrimp feed is a very demanding pellet to produce, partly because of the raw material profile of the formulations, and partly because of the sizes that are required. So normally we're talking about very small sizes, sometimes less than 1 millimeter, up to maybe 1.82 millimeter and beyond. So the LD or compression ratio that would be required would be based upon a combination of the raw material, the formulation, but also the equipment that you're using to pelleting. And most plants you may be extruding for shrimp, but most, I would imagine, are using conditioning and pelleting. So having the right consistency of particle size coming from the grinding operation, having the right consistency from the mixer in terms of CV and mixing of the liquids and the powders that are coming to the conditioning process, preconditioner, and then the conditioning, having the right level of fill of the conditioner I mentioned before, having the right temperatures and pressures of steam coming into the into those conditioners, and then of course the pelleting process itself will respond to what is coming through into the pellet die chamber and the setup of the rolls. So compression ratio, it's very difficult to give a number, just an arbitrary number, because it's going to depend on the size and of course your quality parameter as well. So what standard are you looking for in terms of sinking time? What standard are you looking for in terms of water stability, other pellet quality factors? But generally you'll be talking compression ratios maybe between 25 to 30 plus, depending on the size of the pellet and, as I said, the criteria of quality that you're trying to produce. So, you know, I always say to companies, well, first starting point to answer that question is, what are your pellet mill operators suggesting to you? And if that is not sufficient, then maybe you then try to a higher compression die in order to achieve the necessary quality you're after. But not really practical to give an absolute number, because it's going to vary region to region, mill to mill, and pellet mill line to pellet mill line.
Perfect. Perfect. John's second question, it was a common question from some participants. And you mentioned this during your presentation, and I'd like you to hear you comment a little bit more about which are nutritional strategies that can support and maximize efficiency and profitability.
Okay. Right, that could be another seminar, I guess. But,
yes, I'm sure.
Yeah, just for this. Okay. Well, look, I think apart from the obvious, which is producing formulas that are the most cost effective, that include the most efficient combinations of feed additives that are on the market, whether that's enzymes, whether that's prebiotics, probiotics, acids, whatever those type of ingredients are, that's kind of a given that the nutritionist is going to do that. What I'm really looking at in the course of this presentation is what impact those formulations have on the process efficiency and the cost of production. So, one of the common things I would say, Isabella, is, moisture. If the formulator is running a formulation that is, let's say for argument's sake, 10 or 10.5% moisture, your average moisture coming into the plant is 12 plus, you're going to have a shrink. There's going to be a loss associated with that. Now, therefore, that's why you need that discussion. What can the formulator do to optimize moisture within that formulation, either through addition of water in the mixer, for example, through more efficient grinding, less losses in grinding, or is it going to be more efficient control of cooling and drying? But whatever it is, you should be aiming for a target moisture level that's not going to result in you having a loss compared to those raw materials collectively moisture value that's come in. And I think sometimes formulators don't appreciate what's coming out from the mixer going to the conditioner in the case of pelleted feeds or crumble feeds is very often substandard in moisture content, and the amount of steam that is added cannot compensate enough, either because of temperature differentials which limit it, particularly in this part of the world, in Asia, where you have very warm, hot, humid climates. They're limited on how much steam they can add. So really optimizing moisture is going to be important. That's one example for nutritional. The other would be around the type of raw materials. So optimizing your right oil level in the mixer. And if there is an issue in terms of how much oil is going in the mixer, then you look at the option of fat coating or fat spraying, for example. So the balance of those oils is very important. And I mentioned, if you're going to formulate with raw materials that are going to be difficult to grind, are going to be difficult to pellet, then really analyze the true cost of that, what impact that is from a least cost. What's it saving you in real terms to be using those raw materials against what it's going to cost the feed mill to produce those? If it's still profitable, then fine. But I would question in many cases that discussion occurs and the production just a given a formulation and are expected to produce that. That is not an ideal situation. Each department cannot work in isolation. Purchase, nutrition, production, planning, logistics, they all are responsible for this, and they should all be gathering, on a weekly basis, I would say, discussing what are the issues, what are the changes coming down the line, and what impacts those may have, so you can plan and start to discuss, not just wait for the formulation and then find you've choked the pellet mill, or you're burning the dye because it's too dry. So proper planning, that's what I see as the nutritional strategies to help efficiency from a production perspective.
Mm-hmm. Very good, very good, very clear. One more here, John. What maximum percentage of shrinking losses is acceptable in process as well as storage?
Okay, that's a really good question. I'm sure many companies listening will have their own target. Personally, I would say that for raw materials, anything over 0.5% is concerning. I would say similar for the finished goods. The exception might be aqua. In aqua, it's more demanding. Process losses or returns tend to be higher. So you may be looking at a 1% target on aqua, but certainly no more. But I would also, because I know your company involved in these type of products, for micro ingredients, for feed additives, you know, I never understand the lack of control in some feed plants over these kind of products. They cost thousands of pounds per ton, many of them. And yet, you know, the technology to weigh them and add them into mixer is industry 1 or 2. It's very basic. And you simply shouldn't be operating like that. You should really be handling these products with care. And in terms of stock loss, if you have QR coding or barcoding of these type of products, you can get that stock loss situation down to 0.1, 0.2. And I've seen some companies running at 0 very efficiently on their micro ingredients. And that's a realistic target.
Excellent. Thank you, John. Let me go through one last question. Will you share what should be the standard process loss from pre-grinding up to packing for poultry and cattle feed plant?
So can you just repeat that again, please?
Can you share what should be the standard process loss from pre-grinding up to packing for poultry and cattle feed plant?
Cattle. Okay. When it says blend, I'm not sure if because the terminology is here, blend in the European situation means just mixing raw materials and not pelleting. I'm not sure if they mean that or whether they just mean from the blending and batching process. But process loss would be similar to that previous question, Isabella. So, you know, the losses that you expect, whether it's for poultry feed or cattle feed, should be very similar. And I would be looking to be operating at less than 0.5% loss throughout that line. You need to understand, however, within that loss, how much is due to shrink due to moisture and how much is loss is due to shrink of physical product. And then you can target how to reduce it. So moisture, I've already talked to you about, you know, where are those losses occurring in the process and what you can do to offset those. And if it's physical losses, it's probably due to leaks, to spillages, to wastage, or maybe poor quality product, which is then discarded onto the floor. Those will be the indicators on how you would reduce that back to, as I said, a manageable target of 0.5%. But that to me would be a realistic target. You might want to start at 1%. If you're significantly above that, don't try to get too far too quickly. You know, if you're running at 1.5, 2 now, okay, take a 0.5% reduction, achieve that, and then go another 0.5%, step by step.
John, one last question. Okay, thank you. Thank you for your answer. One last question here. Thank you, John, for a nice presentation. Some amino acid company say that liquid amino acids improve through output, isn't it?
Okay, well, I'll probably leave that to the amino acid companies.
Okay,
to answer.
fair enough.
I mean, I think the point I would make is the amount added is so small. You know, you'd have to present quite a bit of data to me to convince me that that was the case. But if they have evidence and they can prove it, or you can prove it, I'm happy to consider it.
Okay, wonderful.
That's
we have some. Yes, we have some other questions, John, but we will gather them and share with you so that we can forward the answers to all the participants. John, I appreciate very, very much this event and your professionalism and the level of knowledge and details you brought to us during this session. I would like to thank so much the audience that was with us the whole webinar session. I appreciate very much. I hope all of you enjoyed as much as I did. And I kindly ask you all to keep following us in the social media. ICC is bringing this type of knowledge from experts. And this is just the first event. We are having many others during 2023. ICC will be present in VIV, Thailand, next March. I hope we can meet all of you very soon. And also you, John, I hope we can meet finally face-to-face for the first time. Thank you so much for the corporate team from ICC. And I wish you all a great, great rest of week ahead. Thank you, John, and thank you, everyone.
You're welcome. Thank you, everybody.
Thank you. Bye-bye.